So class, this will be section 5.5, dealing with nonlinear systems of equations. So just like it sounds, system of equations in which at least one equation is not linear. And an example of an equation that's not linear would be something with a squared in it, creates a parabola. If we have at least one equation with a that is not linear, it's called a nonlinear system. So for example, here's a system x squared minus y equals 4, x plus y equals negative 2. So if we were to solve this system, substitution method works well, especially when one of the equations is linear. So if you have a nonlinear system, but one of the equations is still linear, substitution method is usually the first go-to to see if you can use that to solve. Let's talk about number of solutions. When we were dealing with strictly linear systems, we had something that maybe looked like this, and that would create one solution. We had, if we had parallel lines, parallel, if we had parallel lines, this was no solution. And we could have two lines on top of each other, and that would have been infinite solutions. Now, when we're working with nonlinear, one of them will have a curve to it. So we could have something that looks like that, where there would be two solutions. We could have where maybe it only touches at one single point, so that would be one solution. And we could have where they will never touch, and so this one would be our no solution. So let's take a look at actually solving the system. So this one that we started on the first slide, x squared minus y equals 4, x plus y equals negative 2. So if I want to use substitution, let's solve this for y. So I'd have negative 2 minus x. I'm going to take that and substitute it right in for my y. So now I have x squared minus negative 2 minus x, be careful with your negative there, equals 4. So this is x squared plus 2 plus x equals 4. Quadratic, we could write in standard form. So this would be x squared plus x plus 2 equals 4. In order to solve a quadratic, let's set it equal to 0. So we'd have to subtract 4, subtract 4. So I have x squared plus x. Put that back up. X squared plus x, and now this becomes a negative 2 equals 0. So let's see if we can factor that. So x squared plus x minus 2 equals 0. So two numbers I multiply to get negative 2 that add up to be 1. Well, I could use this 2 and negative 1. Because my a term was 1, I can immediately jump to say this is x plus 2 and this is x minus 1 equals 0. So my solution is going to be when x is negative 2 and also when x is 1. So those are those two x's that we're going to be working with. But again, we want to figure out where these are crossing, so we need an actual coordinate. So if we were to substitute back in, so I know x is negative 2 and x is 1. I'm just going to use this, x plus y equals negative 2. So I'd have a negative 2 plus 1, or take that back, x is negative 2. So negative 2 plus y equals negative 2. Well, if I start with negative 2, the only thing I could add to it, y has to be 0. And then if I did it at 1, so 1 plus y equals my negative 2. So 1 plus what is going to get me to a negative 2? Well, if I subtract 1, y is going to be a negative 3. So my two solutions where these are going to cross is at a negative 2, 0, and at 1 comma negative 3. So those would be my two solutions to this nonlinear system using substitution. And if we were to graph both of these, we could see they're crossing right there at negative 2, 0 and also at 1 and -3. So those what those two would look like if we did it graphically. All right, another way we can do it is using elimination. So in this case, I have two equations, and neither of these are linear equations. They're both nonlinear equations. So let's do it with elimination. Well, my y's are already stacked nicely to eliminate. So we add to eliminate. So this would be now 3x squared is going to be equal to 12. Divide by 3, divide by 3. X squared is equal to 4. To undo that squaring, x could either be a positive 2 or a negative 2. So that plus minus 2 comes into play. So x is going to be a positive 2, x is going to be a negative 2. Well, let's see what these y values will end up being. I'll just use this top equation. So if x, we'll say x is -2 squared plus y squared is equal to 4. So this would be 4 plus y squared is equal to 4. Y squared then could be equal to 0 if we subtract 4 from both sides. So therefore y has to be 0. I did it with a positive 2 squared plus y squared equals 4. I'm going to have my 4 plus y squared equaling 4. So y has to be equal 0 for the second one as well. So my two solutions would be at -2, 0 and at +2, 0 would be the two solutions to this system. And again, we could see this if we were to graph each one. This is the circle equation that we worked with a little while ago. So it's going to have a radius of 2, because remember the rate equals r squared, and then it's centered about the origin, and then 2x squared minus y squared equals 8 is giving me those two pieces on the outside. So that's it for 5.5. It is in MathXL, due Sunday 4/19 by midnight. Again, do not hesitate to email me with questions. I will reply back within 24 hours with either a written response to your email or a video if you're having trouble with a question. Say, hey, can you make a video of this question for me? No problem. I'll make a video and send it right back to you. I will be at my computer. I write on here every Thursday, but really every Tuesday, Wednesday, Thursday, and Friday from at a minimum 10 a.m. to 11 a.m. to answer your email right away if you send me an email. Or we can do a video chat if you want to during that time. If you want to set up a time to talk, either video chat and another time to send me an email, we'll set something up and we can do some one-on-one work for you. Okay?